Good morning, class. So today we're going to make a quick recording going over the IXL sample work in Unit 3, Lesson 10. So I'll go to the course outline just to show you guys what to expect. So, excuse me, here's Unit 3. So when you get to Lesson 8, it'll just say that it's been dropped, and you can go back and make up some points for previous assignments in Lesson 3 if you don't like your grade. Same thing in Lesson 9. That's the actual discussion. Again, it's been dropped, so you don't have to do anything in that lesson. But when you get to Lesson 10, that is the sample work assignment, and you'll need to click on this lesson, Identify Equivalent Expressions Involving Exponents. And here will be where this recording will go. And it is an essential standard, so it is something that is super important for you to understand going on to Algebra and Algebra 2 as you get into high school. All right, so question number 1. So this is utilizing, first of all, I should say, this is utilizing all of the rules that we learned throughout Unit 3. So power of a power rule, product rule, but we're also going to have to kind of reverse engineer some of these as well, because it won't always be the obvious answer. So like, it's going to start off being easy and there'll be obvious answers, but as we get to higher SMART scores, the answers will be less obvious. So I'll show you what I mean by that reverse engineering here in just a little bit. So this one's a pretty straightforward one. This is a power of a power rule. So power of a power rule, remember, says that we take, when you have an exponent of an exponent, you just multiply the exponent. So 9 times 5 in this case. So 5 to the 9 times 5 power. I'm just writing over. Is equal to 5 to the 45th power. That answer is here and it's available, so we're just going to go ahead and pick that one. All right, and we're already up to a SMART score of 14 to finish. We have to get to a SMART score of 70 to get full credit. Okay, now this one is going to initially look like one that we've never seen before, right? This would be different bases, right? So when we have different bases, there we go. Okay. So when we have different bases, we always said that...
Which expression is equivalent to 9?
Sorry.
Which expression is...
Darn it. I don't know if you guys can hear that, but I keep accidentally hitting the sound button. But it has different bases. So one has a 9, one has a 7. So we would normally say that we can't combine these. However, if you have the same exponent, this is actually a completely different rule that we did not go over in the unit, but if you have the same exponent, you can actually just multiply the bases in this case. That is the only time you can do that. If you have the same base or different bases but the same exponent, you can multiply the bases and combine them. So this, in this case, would be 9 times 7 is 63, and oops, sorry, it's lagging a little bit. So 63 to the 5th power. So the power stays the same, or the exponent stays the same, but we just multiply the bases in that case. So 63 to the 5th, the answer is there, so we're just going to go ahead and select it. All right, this one again is power of power rule, so we're just going to multiply the exponents. So that would be 4 times 7, so 11 to the 28th power, and again, that answer is available. So again, it's power of power, it's a power or an exponent being raised to another exponent. We just multiply those exponents. 4 times 7 is 28, so 11 to the 28th. All right, now this one, again, is a situation where we have different bases. So initially, we would say we can't do anything with this, but we have the same exponent. So the exponent's the same, so we can, again, in this case, last time I said we could multiply them. This time we would divide them. So 6 divided by 2, so we're dividing the bases, because the exponent's the same. So 6 divided by 2 is 3. So this would be 3 to the 3rd, because 6 divided by 2 is 3. That's where we get that one. All right, so same situation. We have different bases, but the same exponent, so we can multiply the bases. So 8 times 6 is 48. Whoops. Gotta click on my little button here. All right, so 8 times 6 is 48, so our answer should be 48 to the 3rd, but notice that that is not an option here. Okay, so we have to figure out which one of these is the same as 48 to the 3rd. So clearly that's not. That's a totally different exponent. That's a totally different exponent.
Which expression is equivalent to 8 cubed times 6 cubed?
All right, so one of these has to be it because they both have an exponent of 3. Now the question is 48 to the third is it equivalent to 1 over 48 to the third? Well, 48 to the third is a really large number. This is a really, really small number. This, however, remember, if we have 1 over, this is like the negative exponent rule, 48 to the third. To make that a positive exponent, we flip it to the numerator and make it positive. So that would be 48 to the third. So that one is the same as 48 to the third. So that's what we're looking for. We're just looking for equivalent exponents. All right, this one, again, we're just multiplying the exponents. So negative 4 times, because this is the power of a power rule. So power of a power rule says we multiply the exponents. So negative 4 times 2 is 9 to the 8th. And again, I'm guessing this is probably not going to be an option yet. 9 to the 8th is not an option. So again, we have to figure out which one of these is equivalent to that. So this is definitely not it. 1 over 9 to the 8th is not the same. 1 over 9 to the 6th is not the same. And again, this was going to be the negative exponent. So I'll just show you that 1 over 9 to the 8th. Again, if we want to make it positive, sorry, there's a lot of lag in me trying to type here right with my mouse. We just flip the exponent to the numerator and make it positive. So if you have a negative exponent in the denominator, you can flip it up to the numerator and make it positive. Or if you have a negative exponent in the numerator, you can flip it to the denominator and make it positive. So when you have a negative exponent, you just flip it from the numerator to the denominator or denominator to the numerator and then make it positive. All right, so in this case, this would be equivalent to 9 to the 8th. So this one has to be our answer. So 1 over 9 to the negative 8th is equal to 9 to the positive 8th. All right, again, we're just multiplying the exponents. This is another power of a power rule. They're giving us a lot of power rules. All right, so this one, negative 2 times negative 7 is 10 to the negative 14th. And again, we have to figure out which one of these is equivalent to that. So remember since it's a negative exponent, we flip it to the denominator and make it positive. So that would be 1 over, and remember we put it in the denominator to make it positive. So since there was no numerator, I mean, technically this is 10 to the negative 14th is the same as 10 to the negative 14th over 1. So we just flip it and make it a positive exponent. So that would be this one here. Yeah, what? What did I do wrong? Hold on, 10. Oh, it was 10 to the positive 14th. Wait, 10 to the positive 14th. What did I pick? Oh, that was an option. Oops. Okay, I wasn't paying attention. All right, that's why you got to pay attention. All right, so this one is a situation where we could do a couple different things here. So this one's combining a couple different rules, but technically we would subtract these exponents. So it'd be 5 to the negative 35 minus negative 5. Because it's a quotient rule. So the quotient rule says we subtract the exponents. Well, they're all negatives, so that makes it kind of crazy. But negative 35 minus negative 5 is really adding 5 to negative 35. Because remember, you subtract the negative, that's the same as adding. So that would be 5 to the negative 30 power, because negative 35 plus 5 is negative 30. Okay, and that is an option, so we're just going to go with that one. All right, this one has the same exponent, different base. So again, we're just going to divide the bases. So that would be 3 to the 6th. Gotta grab my pencil here. All right, so that would be 9 divided by 3 is 3. And the exponent just stays the same. So 3 to the 6th. And I'm guessing that's not an option. So 3 to the 6th is not the same as 3 to the 0 or 3. Okay, so it's got to be one of these two. So we got to figure out which one of these it is. So 1 over 3 to the negative 6, remember, we can just flip it and make it positive. So that would be equal to 3 to the 6. This one would be equal to 3 to the negative 6. This one's 3 to the positive 6 over here. So it'd be that one. All right, we're getting pretty close. This one we just, again, multiply the exponents. They're doing a lot of power rules. Okay, so this one. 1 times 9 is, of course, just 9. So this would be 5 to the 9th power. Oh, and that is an option. So A lot of times the one that we want is not always an option, so that's why we got to check. All right, so this one we multiply the exponents again, another power of power rule. I'm going to go a couple more just to give you guys a few more examples. So this is 3 times 9 is 27. So 6 to the 27th power, and now we have to figure out which one of these is equal to that. So 1 over 6 to the 27th is not the same. This is a totally different exponent. That's a totally different exponent. All right, so the reason why this one is the same is this is kind of crazy because you would never simplify it that way, but we're just trying to figure out which one is equivalent, not simplifying it. This is already simplified. This is a more complicated version of the same thing. So remember, with this one, we would divide the bases because the exponent's the same. So 12 divided by 2 is 6. So that would be 6 to the 27th power. All right, maybe do one or two more. So this one we're just going to add. So this one's finally a product rule. We haven't had any product rule ones, I feel like. So this one, because it's multiplication, it's not, we don't multiply the exponents. This time, when it's a multiplication problem, we add the exponents. So 8 plus 3 is 11. So 12 to the 8th times 12 to the 3rd is 12 to the, why is it not working? 12 to the 8 plus 3 power, which is 12 to the 11th. And that's an option, so we're going with it. And we'll do just a couple more. All right, so this one has the same exponent, so we just divide the bases. So that's going to be equal to 3. So 12 divided by 4 is 3. And the exponent stays the same, so 3 to the negative 4th. So now we have to figure out which one of these is equal to 3 to the negative 4th. That is not. That is not. This one, you multiply the exponents. That's 3 to the negative 32. That's not. And for this one, you multiply the exponents. So 4 times negative 1 is negative 4. So that's it right there. And we're already way past 70, but we're going to do one more just to give you guys a few more examples. So again, you only have to go to a smart score of 70 to get full credit. All right, so for this one, we would multiply the exponents because it's power of a power rule. And 8 times negative 6 is 4 to the negative 48th. So figure out which one of these is equal to that. So this would be 4 to the 3rd. So that's
Which expression is equivalent to the quantity 4 to the 8th to the negative 6?
4 to the 2nd. This one's 4 to the 1st. Now this one is the correct answer. And again, this is a situation where the bases are the same in this case, but the exponents are also the same. So we can do one of two things. We could multiply the exponents, or we could add the exponents here as well. But in this case, that would be the correct answer because we would just do 2 times 2 is 4, 4 to the negative 48th. All right, and that's where we'll stop because we're already well past where we need to go. So that is what we're doing for the sample work. The hard ones are going to be the ones where the obvious answer is not the answer that shows up. So like simplifying this one again, just one more. I'll just do one more just to show you. So this one, we multiply the exponent, so it'd be 5 to the 48th. Oops, didn't click on it. There we go. So this one would be 5 to the 48th because 8 times 6 is 48. And this is, again, a situation where we don't see the correct answer right away, right? That's the simplification of this. That's not an option, so we are going to have to search for which one is the same thing as 5 to the 48th. That's not it. That's not it. This one we would divide, so 10 divided by 2, because the exponent's the same, so that'd be 5 to the 48th. And that's also a rule that we did not really go over in this unit. So that's another one where you just kind of have to be aware of this other rule that was not in any of the lessons that we did. So there is going to be one rule that we did not cover in our lessons. So just be aware. I'm going to purposely pick a wrong answer on this one just because I want to see how they show you the correct answer. All right, so they tell you that if the base is the same, you can just, oh no, that's not the right rule. Where's the rule that we're looking at? We want the base to be the same. Yeah, okay, so these are the ones where the base is the same. So you just add them or you subtract them. Oh, not the base. We want the exponent to be the same. Yeah, that's this one here. So this one is where the base is the same, or sorry, the exponent is the same, and this is another one where the exponent is the same. I thought they would actually tell you what the rule is, but they don't give you the name of the rule. All right, well, that is it for this recording. If you guys have any questions, feel free to book some time with me. If you need help on this IXL, I can always help you. Mrs. Lettinga is also available to book if you need help getting to a SMART score of 70 on this. We are more than willing to help you get there. Do not feel like you have to do it all on your own if you're getting stuck. So with that being said, when you are done with the IXL, just please make sure that it says upload a screenshot. Ultimately, just tell me that so you're going to need to turn it in. You're going to have to turn something in. So I just said upload a screenshot and put it in the Dropbox. So you can just take a picture of. So I use the snipping tool. So if you just type in to the search snip, it'll come up. So the snipping tool, and then the snipping tool will allow you to just take a picture of your score. So the important part is to make sure you take a picture. I will just be looking it up anyways. I'm going to look up your score when you send that to me anyways. So yeah, that's it for the sample work. If you guys have any questions, feel free to book some time with me, and we'll see you guys in the next recording.